The Autonomic Nervous System and Polyvagal Theory. The human nervous system consists of two main parts: the central nervous system, which is the brain and spinal cord, and the peripheral nervous system, which comprises the nerves that leave or return to the brain and spinal cord. The central nervous system is responsible for analyzing all incoming information and stimulation from the body. After deciphering those messages, it sends a response along the peripheral nervous system to the appropriate areas in the body. Most of the information we take in goes directly to the brain for decoding via different afferent, incoming, sensory neurons. Then the brain sends out an action signal via the efferent, outgoing, motor neurons. If the stimulus requires an immediate response, like stepping on a nail or touching a hot pan, the response is dealt with at the spinal cord, and the signal never reaches the brain. The spinal cord senses information like hot or sharp and sends a message via the motor neurons, creating an instant reflex loop that tells the appropriate body part to move. This reaction is known as the reflex arc. The peripheral nervous system branches again into the somatic nervous system and the autonomic nervous system. The somatic nervous system has two main functions. The first is sensory. It communicates along the afferent pathways, bringing information back to the central nervous system from our sense organs using various types of sensory receptors. Mechanoreceptors detect changes in pressure, thermoreceptors gauge changes in temperature, and nociceptors sense pain. The somatic nervous system also brings information from our senses of sight, taste, smell, hearing, and equilibrium, and then sends the brain a message that paints a picture of our outer and inner worlds. The second function is to carry signals from the central nervous system along the efferent neural pathways to our skeletal muscles for controlled movement. The autonomic nervous system communicates with our organs and glands. It is responsible for regulating all involuntary and unconscious functions of the body like digestion, maintaining blood pressure, regulating heart rate, and incognizant breathing. An easy way to think of that is that the somatic nervous system relays all thinking actions, whereas the autonomic nervous system is for non-thinking functions. The autonomic nervous system divides again into the sympathetic and parasympathetic pathways. Although these two pathways are mostly antagonistic, they are meant to function concertedly to maintain the regularity of involuntary functions. Changes in our physical, mental, or emotional condition dictate which pathway is dominant. The sympathetic nervous system is known as the fight or flight response, meaning it is more active in response to stressful situations. The parasympathetic nervous system, also known as rest and digest, is more engaged when we are relaxed, such as when we are sleeping or eating. It is also vital for sexual organ function. With terms like fight or flight and rest and digest, it is easy to think that these two pathways oppose each other, as though one is always fighting for dominance. But in reality, they work mostly with each other in contrast to maintain homeostasis throughout bodily functions. What I mean by working in contrast is that the difference between the two helps bring out the aspects of the opposing pathway. Like adding black to a painting brings out the brightness of white and the vibrancy of the colors. The autonomic nervous system, through contrasting stimulation or regression of the sympathetic or parasympathetic nervous system, helps increase the opposing effects to maintain homeostasis. The acute sympathetic response is there for times of extreme danger, but most of the time, we are neither fighting nor running for our lives. Neither are we sleeping or digesting. We're most often somewhere between these two states. I have heard and read many explanations that the two systems function like a switch. When one is on, the other is off. When we are in a highly stressed state, this might be true, but the body is much more intelligent and complicated than on or off. In activities such as sexual arousal and ejaculation, the sympathetic, parasympathetic, and somatic nervous systems are all active. If the primary function of these two systems is to regulate the balance of life-providing functions like pumping blood, controlling blood pressure, regulating hormone secretion, and digesting food, then the on-off analogy doesn't make sense. A better way of understanding the cooperative roles between the sympathetic and parasympathetic nervous systems is to think of them as hot and cold faucets. When both systems are functioning correctly and one is not overstimulated, the water is nice and warm. This balance of the two functioning systems is called autonomic tone. As the situation dictates, more hot or cold water can be added, and when needed, the water can be all hot or all cold. In reality, though, there is no switch or faucet. Both systems are functioning, releasing hormones and neurotransmitters titrated as needed throughout the body to handle whatever situation we are experiencing dynamically. Imagine you are asleep in bed, and then all of a sudden, a loud beeping noise wakes you. The smell of smoke fills the room. In an instant, you are completely alert and super focused. Your house is on fire and you need to get out. Your heart starts racing, pupils dilate, blood vessels constrict to push more blood into your muscles, and your breathing becomes shallow and rapid. Now, imagine you're getting ready to give a big speech to hundreds of people and you have no idea what you're going to say. As you walk onto the stage, you feel a tightness in your chest as your heart starts beating faster and your mouth feels dry. You freeze, unable to think, move, or speak. One more scenario. You're watching a horror movie, and the main character is hiding under the bed as the killer enters the room. You feel anxious, you start sweating even though it's not hot in the room, and you even begin to hyperventilate. These three situations are all different. In the first scenario, you are in real danger, and your sympathetic nervous system responds precisely how it is supposed to. But in the other two situations, there is no actual danger, yet, because your mind perceives the situations as dangerous, you have a sympathetic fight or flight response. It is important to recognize that actual and perceived danger elicit the same reaction. Although these are examples of a more extreme response, in our busy society, the majority of people live in a constant state of stress and anxiety. This chronic stimulation of the sympathetic nervous system leads to major cardiac and respiratory illnesses, digestive issues, and other health problems. Because so many people deal with chronic stress and therefore are in chronic sympathetic activation, the sympathetic nervous system is discussed in a negative way, and probably for good reason. Most people need to learn how to decrease chronic stress and increase parasympathetic tone to bring balance. But there is another way to look at the sympathetic nervous system, and that is activation and mobilization. When we wake from sleep, sympathetic tone increases. The shift tone is minor, but we need this activation to get going. Often we try to aid it by drinking coffee because we are not getting enough rest to restore our baseline. The more activity we do, the more the sympathetic nervous system works to give us the energy we need. When we start to slow down, the parasympathetic nervous system slowly applies the brakes, and this harmonious relationship continues to support our lifestyle and needs. The sympathetic nervous system originates in the thoracic and lumbar regions of the spine. Preganglionic nerves exit the spine and connect to the sympathetic chain of ganglion, which are located near the spine. From here, postganglionic nerve fibers travel to the organs, blood vessels, and glands. The postganglionic fibers are myelinated, which enables them to send the signal much faster than the unmyelinated preganglionic fibers. This allows the signal to travel to the organs much quicker than it does in the parasympathetic nervous system, where the unmyelinated preganglionic nerves are much longer because the parasympathetic ganglia are located near or within the target organs. This myelination allows for a quicker sympathetic response. The sympathetic nervous system functions primarily to react quickly to perceived danger or potential threats, i.e., fight or flight. So, the bodily response is to mobilize immediately. The pupils dilate so we can see more, the heart beats faster, and the blood vessels constrict to increase muscle perfusion. The bronchi in the lungs open up so we can breathe better, the adrenal glands release adrenaline, giving us a rush of energy, and the urinary and digestive functions are inhibited. The parasympathetic nervous system, para meaning around, originates above and below the sympathetic nervous system in the skull and sacrum. From the brainstem, cranial nerves 3, 4, and 5 travel to the eyes, face, and mouth, controlling constriction of the pupils, salivation, and lacrimation, the flow of tears. Cranial nerve X, known as the vagus nerve, travels to the majority of the abdominal organs and viscera. The vagus nerve is the most significant component of the sympathetic nervous system. It's responsible for slowing the heart rate and contractility, tightening the airways in the lungs, moving food down the digestive tract, limiting inflammation, and helping the immune system. From the sacrum, parasympathetic fibers connect to the kidneys, bladder, and sexual organs. The parasympathetic nervous system physically functions to aid in rest and recovery, digestion and excretion, and reproduction. The autonomic nervous system's function and influence are significant when it comes to social engagement, mood, and outlook on life. Dr. Stephen Porges developed the polyvagal theory based on the two branches of the vagus nerve that control most of the parasympathetic nervous system, the ventral vagal complex and the dorsal vagal complex. His approach divides the autonomic nervous system into a three-part system consisting of the ventral vagal complex, sympathetic nervous system, and dorsal vagal complex. Although the ventral vagal and dorsal vagal complexes both stem from the vagus nerve, they function and respond very differently. The dorsal vagal complex is responsible for most digestive functions and regulates organs below the diaphragm. It is the older primal evolutionary branch and is responsible for our earliest stress response, also known as the freeze response. In situations involving a high degree of fear, overstimulation of the dorsal vagal complex can lock us up, rendering us unable to move or act, as we see in many reptiles and some mammals reacting to extreme danger. When the dorsal vagal complex is in dysfunction, we become withdrawn and antisocial. Increasing the dorsal vagal complex tone calmly and peacefully, i.e., not under stress or danger, brings us to a state of deep relaxation, as we experience in meditation. The ventral vagal complex regulates the functions of the heart and the respiratory system. It is associated with social engagement and is most dominant when we are healthy and happy. The polyvagal theory expresses the reactive relationship of the autonomic nervous system in a hierarchical state of safety or danger. The ventral vagal complex, at the top of the system, is related to how we conduct ourselves in a positive manner around others, interact with our friends, family, and strangers, and present ourselves in social situations. If we sense danger or a threat, then the sympathetic nervous system reacts with the fight or flight response. If the situation is perceived as life-threatening, then the dorsal vagal complex reacts with immobilization, disassociation, and shock. If we are in a place where we feel safe, then the stimulation of the sympathetic nervous system moves us towards a healthy state of mobilization where we can work, dance, play, do sports, and physically interact. The dorsal vagal complex adds balance by bringing us into a state of rest, rejuvenation, and deep relaxation. In this model, we see the mutable interactions of the autonomic nervous system and the importance of each part's function concerning a healthy and safe state versus reacting to a threat or danger. The polyvagal theory maps out the response of the autonomic nervous system when stimulated while feeling safe or feeling stress or danger. In a healthy state of balance, we are primarily stimulating the VVC. When we experience changes from external or internal stimuli, we can quickly shift from safe to unsafe or vice versa and switch branches of the ANS. We can also get stuck in the SNS or DVC if we remain in a chronic state of stress.